Modern remote sensing totally relies on the computer processing system. So in this time, during these times, we are actually dealing with the computer age. So how we can extract the data and how these data can be used for the processing of the different land uses. So in this way, the study of the remote sensing is very important. In remote sensing, we are using the high resolution maps and low resolution maps. In high resolution maps, the picture is taken closer to the surface, and in low resolution map, the picture is taken from far from the Earth's surface. So like we have nowadays the cameras which are which are used for the taking the picture of the certain scenes. So in high resolution cameras, the pixel size may be from 18 to 24 megapixels. So in this way, we can take the high resolution picture. But once those cameras are contains 5 megapixels, so those are low resolution cameras. So in high resolution map, the pixel size is smaller than the low resolution pictures. So in this way, we can enlarge the picture as compared to the low resolution maps. So in remote sensing, the orbiting Earth satellites which carries remote sensing systems is become a major branch of the geographical research. They can image and monitor large geographical area or the entire Earth. So in this slide, we are actually dealing with the orbital circles of the satellites. These are actually the circles which are actually controlled by the low orbit, Earth orbit. This is called the LEO, which is actually closer to the Earth's surface, move closer to the Earth's surface, and it has sun synchronized phenomena. So many satellites designed for remote sensing use a sun synchronized orbit. As the satellite circles the Earth, passing near each pole, the Earth rotates underneath it, allowing all the Earth to be imaged after repeating passes. The orbit is designed so that the images of a location acquired on different days are taken at the same hour of the day. In this way, the solar lightning conditions remain about the same from one image to the next. Typical sun synchronized orbit take 90 to 100 minutes to circle the Earth and are located at a height of about 700 to 800 kilometers above the Earth's surface. This is called the LEO satellites or low Earth orbit. So here we have the example of the LEO, which has a polar orbit. Now it has the distance from the Earth is about 700 to 800 kilometer or sometime about 850 kilometer from the surface. But GEO is actually the Earth synchronized satellite. It has the height of about 30 to 36,000 kilometers from the surface, and it is actually following the speed of the Earth or Earth synchronized orbit. So this is another orbit used in remote sensing is the geostationary orbit. Instead of orbiting above the polar or poles, a satellite is geostationary orbit constantly revolves above the Earth. The orbit height is about, as we have discussed earlier, is more than 36,000 kilometers, is set so that the satellite makes one revolution in exactly 24 hours in the same direction that the Earth turns. Thus, the satellites always remain above the same point on the equator. From this high vantage point, The geostationary orbital provides a view of the nearly half of the Earth at any moment. Geostationary satellites are ideal for observing weather, and the weather satellites images readily available on television and internet are obtained from geostationary remote sensors. So geostationary orbits are used by communication satellites since a geostationary orbital remains at the fixed position in the sky for an Earth-bound observers. Now, medium Earth satellites are smaller to LEO satellite in functionality. They have a larger coverage area as compared to the LEO satellite system.